So in our previous example of a counterexample, you notice that it was relatively easy to find. All I had to do was take the very first number, plug it in, and found out that that indeed was a counterexample. And in general, when trying to find counterexamples, that is one of the strategies that you can apply. You just plug in some values and check. You take whatever claim that you have, you plug in some values for the variables, and you check whether or not it's true or it's false. So sometimes this works, like in the previous example, it worked, but sometimes you can try lots of different cases and you're not getting a counterexample, you're not getting a counterexample, etc. So the second strategy is a little bit more nuanced. That strategy is as follows. So that second strategy is study the claim in detail and try to reverse engineer a counterexample. So let's go ahead and see this in action. So let's say that I have a conjecture. So here is my conjecture. Say x and y are real numbers where x is not equal to 3. Then, if this equality is satisfied, then y has to be 0. So I could indeed try strategy number 1 and start plugging in values and checking. So let's make sure that we recall this implication and the truth table for this. So just briefly, let's go ahead and recall. If this is my hypothesis and that is my conclusion, the truth table for the implication is as follows. So the only time when the implication is false is when the hypothesis is true and the conclusion is false. So I could try strategy number 1, and if I did that, there's a whole heck of a lot of values that I could try, right? I'm talking about all real numbers here. So I could try any x, and that's not 3, and any old y. So I could try using strategy number 1, I just pick some values for x and y and check and see. So let's say that I just picked x equals 1 and y equals 1. Let's see what this hypothesis right here would say. Well, if x is 1, that's going to be 1 squared times 1. So that's going to be a 1 on the left-hand side equals 9. So in this example right here, our hypothesis, our P, is going to be logically equivalent to the statement 1 equals 9, which is false. And then my conclusion, well, that's logically equivalent to y equals 0. And in this case, y is 1, y is not equal 0, so that thing is false. So what do I have? I have P is false and Q is false. Well, if P is false and Q is false, darn it, my implication is true. That is not a counterexample. It does not show that this claim here is false. So this is not a counterexample. And you could continue on. You could try different values of x and y, et cetera, and you might get different combinations, et cetera, et cetera. But A lot of the times you're going to be finding that this implication here is true, but we're searching for a counterexample. So let's go ahead and apply strategy number 2 and study the claim a little bit more in detail to try to reverse engineer a counterexample. So using strategy number 2, let's go ahead and see. Okay, I want a counterexample. So I want this implication to be false. So if I want this implication to be false, that means my conclusion has to be false. So this thing has to be false. So I want y not to be 0 because I want my conclusion to be false. And now, since I'm trying to find a counterexample, I want my hypothesis to be true. I want this thing to be true. So let's go ahead and study this in detail and see if we can't figure out some possible value for x. So I want my conclusion to be false and my hypothesis to be true. So looking at this equation right here, I note something interesting. So if x squared y equals 9y, I can divide out y on both sides, because y is not 0. And I get x squared equals 9. And if x squared equals 9, well, that means x could be plus or minus 3. So, interesting. All I need to do is, let's try x equaling negative 3, because that case wasn't excluded in our claim. And let's let y be any value that is not 0. So let's try x equals negative 3 and y equals 1, and let's see what happens. Our hypothesis P is then logically equivalent to this statement. So x squared, that's going to be negative 3 squared times y is 1 equals 9 times 1. And we see that, yeah, 9 equals 9. That is a true statement. And what about our conclusion? Our conclusion here was the claim y equals 0. Well, y in this case is 1. And I'm sorry, 1 does not equal 0. That is false. So here I have successfully been able to then construct an example where my hypothesis is true and my conclusion is false. Therefore, x equaling negative 3 and y equal 1 is my counterexample. It shows that this claim right here is not true. It is not a theorem. It is a false statement. And so you can see how this second strategy right here, I had to reverse engineer my counterexample. I knew that I was looking for an instance where my hypothesis was true and my conclusion was false. So I went ahead and set up that situation and figured out what the possible values could be. And that led me to my particular counterexample, which oftentimes can be more efficient than just randomly plugging in values and checking. Sometimes you need to reverse engineer your statement.